Hi everyone. So in this problem, I'll be proving the last problem of this subsection, and I'll use ideas from congruences, and I'll present those ideas soon in the future videos, probably within this week. So yeah, so let's continue. So how can we solve this? So it tells you that let P and Q be primes with P and Q both bigger than or equal to 5. Prove that 24 divides P squared minus Q squared. So what can we do with this? So 24 can be written as 8 multiplied by 3. So that is 2 to the power of 3 multiplied by 3. So first, apply the division algorithm and divide P and Q by 3. So then P is equal to 3 multiplied by K plus R1, and Q is 3 multiplied by L plus R2, where the respective R1 and R2 are bigger than 0 and less than 3. So R1 and R2 are less than 3 and bigger or equal to 0. So then what you can do is that we know that P is congruent to R1 mod 3. So, well, and also, let's just write things down. And also Q is congruent to R1, R2 mod 3. We cannot really have both R1 or we cannot have any of the Ri's being 0 because we know that P is a prime and Q is a prime bigger than or equal to 5. So we must have that R1 and R2 are both not equal to 0. So that gives the rest of the possibilities that are left, which is, so the rest of the other possibilities are, let's see, so we can have 1, we can have 2. So if Ri is equal to 1, then you have that P squared is congruent to 1 mod 3, and Q squared is congruent to 1 mod 3. So then P squared minus Q squared is congruent to 0 mod 3. Okay, so that's good. If R1 is equal to 2, then P1 or P squared is congruent to 2 squared, which is 4, and that is congruent to 1 mod 3. And similarly, Q squared, if R2 is equal to 2, then we have that Q squared is, so let's just set this to be Ri. Then Q squared is also congruent to 1 mod 3. So then we also have P squared minus Q squared is congruent to 0 mod 3. Okay, perfect. So, alright, so next is that we'll divide P and Q by 8. So P is 8 times K prime plus R1 prime, and Q is 8 times L prime plus R2 prime, where Ri, R1, and R2 are less than 8 and greater than or equal to 0. Okay, so here P and Q is odd, so then we can't, so if they're odd, we cannot have even numbers. So as 8 is a multiple of 2, so we cannot have Ri being 2, 4, 0, 6, etc. So Ri is not equal to 0, 2, 4, 6, just by the fact that P and Q are odd prime. So then what is left is Ri can equal to 1, it can equal to 3, it can equal to 5, it can equal to 7. So let's pick them one by one and see what happens to P squared and Q squared. So if P is congruent to 3 mod 8, and then P squared is congruent to 9, which is congruent to 1 mod 8, and similarly we have if Q is congruent to 3 mod 8, Q squared is congruent to 1 mod 8. Okay, so then if P is congruent to 5 mod 8, then P squared is congruent to 25, which is 1 mod 8, and if P is congruent to 7 mod 8, then P squared is congruent to 49, which is 1 mod 8 as well. And similarly for the Q. Therefore, P squared minus Q squared is congruent to 0 mod 8 in both cases. In both cases. So that means that 3 divides P squared minus Q squared, and 8 divides P squared minus Q squared. So as the GCD between 3 and 8 is equal to 1, so that means that 3 times 8, which is 24, divides P squared minus Q squared. Yeah, and then we're done. All right. Yeah, that was great. And yeah, I'll see you guys in the next video. Bye.